Okay, now we're moving on to the fun part, polynomial division, when we have a binomial instead of a monomial. So we've got two terms instead. There's two different methods of doing this, and I don't care which one you pick. So I'm going to show you both ways, and then you can pick which one you want to do for the problems. However, the first way is polynomial long division. The second way is synthetic division. Now, synthetic division does not work all the time. Polynomial long division will. So I'm going to start off with polynomial long division. This is probably the most common, the way our parents learned. And it's just like dividing regularly. So I'm going to look at this problem here, and I'm just going to write it up here so we can kind of talk about it. So we have 672 divided by 21. So going back to when you first learned division and you didn't have calculators, you're looking and seeing, okay, 21, can it go into 6? No, it's way too big. So you look then and you look and see, hey, can it go into 67? Hey, 21 can go to 67. 21 can go into 67 3 times. And then you say 3 times 21 is 63. And you write that below and you subtract. Well, 67 minus 63 is 4. And then you bring down this 2. We have 42, and we say, now, how many times can 21 go into 42? Well, what about 21 times 2? And that goes up there, and I've got 21 times 2 is 42, and I subtract, and it zeroes out, and my answer is 32. So that's regular division. That's kind of what we're going to be doing with polynomials now. So this is an example of what we're going to be doing. I'm going to keep this example up here, but I actually want to start with this one down here because I think it'll be easier for us to walk through if we actually do one together. Okay, so yesterday we were doing polynomials, but we didn't have a binomial. We just had one number. We had 3x, or we had 4, or we had 4x squared. Now we've got two terms. That's what's changing this up. Okay, whatever comes first goes inside your house. So we're going to draw our division house, and we're going to put 4x squared plus 23x minus 16 inside the house. What comes second goes outside your house. X plus 5 goes outside. That's step 1. Now, for purposes of this problem, what I do want you to do is change this minus 16 to plus 15. It'll make it a little bit easier on us. So change that to plus 15 for me. Change it in our problem as well. We could do minus 16. It's just not going to come out as pretty. This one will come out prettier for our first problem. So go ahead and change that to plus 15 again if you haven't already. So I've got 4x squared plus 23x plus 15 divided by x plus 5. So we want to see how many times can x plus 5 go into that polynomial. Here's how it's going to be done. First step, you're going to look at your first term. In this case, we have x. And you're going to look and see how many times can x go into 4x squared. Or in other words, x times what give me 4x squared? Well, I'm missing a 4. So I need a 4. And I only have one x and I need 2 x's. So I need to multiply by 4x. If I multiply 4x times x, I'm going to have 4x squared. That's my answer. So 4x, you're going to put that above this 23x. And the reason we're not putting it above here is because this only has an x to the first power, where over here we're dealing with x to the second power. So that's why we're doing that. So I said x times 4x gives me 4x squared. And I'm going to put 4x squared below here. And now I still have this other term to deal with. I can't forget about this plus 5. So now I say plus 5, or 5, times 4x is what? Well, 5 times 4 is 20, plus the x is 23. So I have 20x. So I have 20x, and I'm going to put it right below the x. So you just want to keep all of your terms and variables with the same last name lined up. Okay, now here's the next part. You're going to change the sign. So since these are all positive, we're going to change them all to subtraction underneath here. If they were all subtraction or negative, we would change them to all positive. You're changing the sign of everything underneath. Well, 4x squared minus 4x squared, that goes away. And you want to make sure that happens. If that does not happen, you did something wrong. You need to go back and try again. So if your first term does not cancel out, that's the whole point of this, try to get it to cancel out, you did something wrong. Then I have 23x minus 20x. I'm left with 3x. Okay. Then I've got to move this down. So I have plus 15. I'm going to erase this up here because I think it's a little confusing. Get rid of that. That was a multiplication. Okay. Now I'm going to do the same thing again. I'm going to start my whole process over. I'm looking at my x. And I'm saying x times what gives me 3 x's? Well, I've got 1 x. I need 3 x's. So times 3. So positive 3 is going to go up here above my no name spot. Well, if I multiplied 3 times 3x, I got 3x down here. But I also have to do the same thing for the 5. 5 times 3 is 15. Now I go through and I change all the signs. Minus, minus. Well, 3x minus 3x goes away. 15 minus 15 goes away. And you're left with, up here, is your answer. You're left with 4x plus 3 is your answer. Now, again, like we talked about with the monomials, a great way to check it is to take your answer multiplied by what you divided by. So 4x plus 3 times x plus 5. We're going to have to FOIL it, or if you like box method, I know a lot of you like box method, so I'll do box method. I got 4x, 3, x, and 5. 4x times x is 4x squared. 3 times x is 3x. 4x times 5 is 20x. 5 times 3 is 15. Well, these two are the same, so when I go to combine like terms, I have 4x squared plus 20 plus 3 is 23x plus 15. If you look, that's what I started with. So this, in fact, is my answer. I know it's a lot of steps. Take a deep breath. Y'all have got this. Y'all are smart. I believe in you. It's just like dividing. It just takes practice. So if you aren't already, please get a piece of paper out. Start doing this with me. Okay? Watching your coach run the drills is not going to make you get better. And it's even harder that I'm not there to kind of answer any questions and walk you through this in person. So please write it out with me. And we can talk about it over Zoom later. Okay. Number next. Divide x squared plus 3 by x minus 1. Again, the first thing goes inside x squared plus 3. And the second is x minus 1. Now, if you notice, the other one, I had an x squared, I had an x, and then I had just a regular number. Here, I just have an x squared and a regular number. So one rule is, over here, when a power of x is missing, when written in standard form, use a 0 as a placeholder. So you need to make sure and remember this rule. This is important. So I've got x squared, but I'm missing an x. I'm missing an x. So instead, I'm just going to say plus, I've got 0 x's. I've still got to have them there, but I've got 0 of them. And then I still have the plus 3. So that's what it means by adding a 0 placeholder. If we were missing x squared, or we were missing extra third power, it can go up to as many powers as we need to. You just plug in a 0, and then whatever x to the whatever power that you're missing. And now we're on the right track to do exactly what we did on the last problem. So if you look on the last problem, what we did is we took x, whatever was in front, on the outside, we said this number times what gives me this first number inside here. Well, in this case, it's x times what gives me x squared. Well, I'm just missing one more x. I got to multiply by x, 1x. So 1x, or I'm just going to say x. I'm going to put it above here because remember, we're lining up. I wouldn't put the x here because I've got a 2. I can't put a power of 1 above the 2. Power of 1s have to line up with each other. Okay, so 1x. Well, if I multiplied him by x, I got to multiply negative 1 by x. So negative 1 times x, and that was my bad. I forgot to write it down here too. X squared. Negative 1 times x is negative x. I'm subtracting x. And if you need to write that 1 there, that's totally fine. It's up to you. Now I go through and I change all the signs. So this was positive, I would change it to negative. This one's negative, so I change it to positive. Well, x squared minus x squared goes away. Then I have 0 plus an x. 0 plus an x. So I'm left with x, 1x. And again, you can write 1 if you want. If you don't need it, that's fine. And I bring down this 3 plus 3. Now I start the whole process over again. And I say, hey, this times what gives me x? Well, x times what gives me x? 1. So plus 1. Then I have negative 1 that has to be multiplied by 1. Well, negative 1 times 1 is negative 1. So x minus x. Let me go through and change my signs. Change to a negative because it was a positive. Change to a positive because it was a negative. X minus x goes away, and I've got 3 plus 1 is 4. Now, we haven't had an example like this where we have a remainder. We haven't done one of these yet. So when you don't zero out like we did up here when everything just canceled out and it was all beautiful and pretty, and that didn't happen, you're left with a number here. So we're left with this 4. We can't just forget about him. He's still a part of it. So since he's positive, we're going to add the 4. But when we add the 4, it's 4 over what we divided by, x minus 1. And this is your answer. And the reason is because we still have this 4, which is needed to be divided by this. But I can't really, that's as simplified as it gets. X times nothing gives me 4. There's nothing I can do to get to that. So that's why we would just write it like that. So that's your answer. X plus 1 plus 4 over x minus 1. Okay, let's try number 3. This is what goes inside. 6x squared plus 7x plus 2 divided by 2x plus 1. If you notice, everything's there. I've got an x squared, an x, and a 2, so I don't need to put any zeros in as a placeholder. So I start with the very first one. 2x times what gives me 6x squared? Well, 2 times what gives me 6? 3. X times what gives me x squared? Well, just missing one more x, so x. So 2x times 3x gives me 6x squared. Oops. Found my blue. 6x squared. And remember, I've got to do it to this too. So 1 times 3x is 3x. Now I go through and I change all my signs. So they're all positive, so they change to negative, or subtract, however you want to say it. 6x squared minus 6x squared goes away. Remember, that's our goal. 7x minus 3x is 4x. And I bring this plus 2 down. Then I start over. And I say 2x times what gives me 4x? Well, times 2, right? 2x times 2 is 4x. So I have a plus 2, 4x. And then I have to do the same thing over here. 1 times 2 is 2. And I go through and change all my signs. They're all positive, so I change them to negative. 4x minus 4x goes away. 2 minus 2 goes away. So I'm left with a pretty answer of 3x plus 2 is my answer. So not too bad. That is polynomial long division. There's another way. I actually think this way is easier. And it works only if, let me see if I can find it over here. It works only if there's not a number in front of the x. So if it were like 3x minus 7, it wouldn't work. So here we go. What you're going to do for synthetic division is take whatever number's here. So if it's x plus 3, x minus 7, x plus 6. Remember, there's no number in front of the x. That's the only way synthetic division works. What you're going to do is you're going to switch it. So if it's a plus 6, you're really going to use a negative 6. Because like if we were to solve this out for 0, x minus 7 equals 0. And we solve this out, I would really be adding 7 to both sides, and I get x equals 7. So that's why you're taking the opposite. Y'all have done that before. And we're going to put that up here. Just leave it floating there. Then you're going to draw an upside down division box. I know, it's really weird. And here's the next part. Again, you have to make sure you have numbers for x squared, x. You will have to use a placeholder if you don't already have it. And all you're going to do is take the numbers in front and the sign, of course, of your values. I don't want the x's there. So I'm going to write 3, negative 29, and positive 56. And just write them to where they're spaced out again. This time you don't want x's, x squareds. You don't want any of that. So that's how you write it. This first part goes inside again, but it's a upside down, and we don't want the x's, x squareds. Then you take whatever number is here, and you change the sign. So if it's plus 7, we would put negative 7. Since it's minus 7, we put positive 7. Okay, step number first. All you're going to do is draw an arrow, and you're just going to move that 3 down. That's it. That first number, you're just moving down. Next step, you're going to do 7 times 3. And 7 times 3 is 21. You're going to put that number here on your next row. Then you're going to add these up. Well, negative 29 plus 21 is negative 8. Then you're going to do the same thing we did with the 3. You're going to say 7 times negative 8, which is negative 56. And we're going to write that up here. And we're going to add these two together. Well, 56 minus 56 goes away. It's just 0. And whatever's left over here is your remainder. So in this case, we've got 0 as a remainder. If there was another number that's very last, that's your remainder, like we had for regular division. So 3x minus 8, x minus 7. You could FOIL or do box method. And I've got 3x minus 8, x minus 7. Well, 3x times x is 3x squared. Negative 8x, negative 21x, and positive 56. I'm going to combine my like terms, negative 21, negative 8x, and I'm left with 3x squared minus 29x plus 56, which again is what I started with. So that is my answer, 3x minus 8. And again, I think this way is easier, just reference. However, it doesn't work for everything. It wouldn't work if there was a number in front of the x. Okay, let's try one more. So I'm taking x plus 2 is what I'm dividing by. So I'm going to change it to be a negative 2. Draw my upside down division box. And again, I only care about the numbers. So I'm only looking at what's in front. Well, there's nothing here. Negative 14, 51, and negative 54. So if there's nothing there, I've got 1 x to the third power, negative 14 x squareds, 51 x's, and negative 54. And again, I don't want any of the x's in here, just numbers. Then we start. And I bring this guy down. That step first. Next, I'm multiplying. Negative 2 times 1 is negative 2. And we're going to add these together. Negative 14 minus 2 is negative 16. Then we do it again. Negative 2 times negative 16 is positive 32. We're going to put it up here. And we're going to add these two together. So I've got 83. Then we do it again. Negative 2 times 83, which gives me negative 166. And remember, whatever's down here in this box, or at the very last row, is my remainder. It's not a part. So negative 54 minus 166 is negative 220. So now when I go to write it out, I've got this 1. And remember, we started with x to the third power. So now for our answer, we're going to start with x to the second power. You're doing 1 less. So I'm going to start with 1x squared. And I'm just going to say x squared if that's okay. Minus 16x plus 83. And then we have this minus 220. Remember, we always have to put it over this, what we're dividing by, x plus 2. And that is your answer. Okay, either way works for me if you're a long division kind of person or a synthetic division kind of person. I don't care which way you choose. Again, long division works for everything. Synthetic division only works if there's not a number in front of the x. Go ahead and work on the practice problems and get that homework done. Thanks, y'all.